In this video, I will go over rates of change in tangent lines. Let's start with the definition. The average rate of change is the change in y over the change of x, which is equal to f of x2 minus f of x1 all over x2 minus x1, which is equal to f of x1 plus h minus f of x1 all over h. Given the following picture, we can see the average rate of change is the slope of the secant line between 2 points. As Q approaches P, the length of H will approach 0. We say the tangent line to the curve at P is the line through the point P whose slope is the limit of the secant line. Let's take a look at an example. Let's find the average rate of change of the function f of x is equal to x cubed plus 1 over the interval from 2 to 3. To find the average rate of change, again, it is going to be the change in y over the change of x, which is equal to f of x2 minus f of x1 all over x2 minus x1. Again, we were given the interval from 2 to 3, so all we have to do is plug that in and look for f of 3 minus f of 2 all over 3 minus 2. All right, again, we were given the function x cubed plus 1, so plugging in our values 3 and 2 into our function in the numerator, we will get 3 cubed plus 1 minus 2 cubed plus 1 all over 3 minus 2. Calculating that, we will see in our numerator, we will get 28 minus 9 all over 3 minus 2. And finishing off that calculation, we will get 19 over 1, which is equal to 19. So again, we can see the average rate of change, also known as the slope of the secant line between the points 2 and 3 for this function, x cubed plus 1, is going to give us 19. Let's take a look at one more example. Let's find the slope of the tangent line this time to the parabola y equals x squared at the point 2, 4. By analyzing the slopes of the secant lines through the point 2, 4. So let's write an equation for the tangent line to the parabola at this point. So before we can find the tangent line, let's think about analyzing what's happening with the secant line. All right, so we're given a point 2, 4. And to analyze the secant line, we need a second point some distance away. And so I'm going to call that point Q. And its distance away from our point, I'll call h. So our x value is going to be 2 plus h. And therefore, our y value with the function x squared is going to be 2 plus h squared. All right, so the secant line slope is going to be equal to, again, that change in y over the change of x. And so for this problem, it's going to be 2 plus h squared minus 2 squared all over 2 plus h minus 2. All right, foiling out our numerator, I will be at h squared plus 4h plus 4 minus 4 all over h. Simplifying a bit more, I will be at h squared plus 4h over h, and one more little simplification with the h's, and we are left with h plus 4. All right, so let's analyze this. Again, this represents the slope of the secant line. And as h approaches 0, we said the secant line slope of h plus 4 is going to end up just approaching 4, which is now going to be our tangent line. So our tangent line we were told is going to go through the point 2, 4, and we said again the slope of our secant line as h approaches 0, our slope will be 4. And then, of course, just to find the equation of that tangent line, think back to algebra, we just need good old y equals mx plus b. And so we were told our y value is 4, our slope is 4, and our x value is 2. And solving for b, we get b equals -4. And so our final equation to the tangent line will be y equals 4x minus 4.